I'm going to start talking to you guys about visual analytics and a little bit about what it means actually, and why is it interesting, and how, let's say, more or less we should think about it, especially in terms of the other things that you have studied before you came to the course. And since you have, well, one of the pre-requirements of the course is that you have done machine learning, right? And not visualization. And ideally, we would have a pre-requirement of visualization also, because then this would be more like an applied course instead of having to deal with both, let's say, learning the visualization concepts and then applying them more or less at the same time. I think most of you are taking the visualization course at the same time, so that's good. But that it's also a little bit complex because we have to somehow, let's say, juggle these two things together in order to learn the concepts and then apply them at the same time. But what matters is that the machine learning is a pre-requirement. And so the first thing that usually when I talk about visual analytics with people is that I like to start from the starting point of machine learning, because usually, at least nowadays, machine learning is a kind of a buzzword, and I mean, everyone wants to have a piece of the cake, right? Let's say, because I mean, there's a lot of money involved. There's a lot of, I mean, it's a good opportunity for good work and careers and so on and so forth. So everybody's kind of like trying to take a piece of the machine learning pie, and I mean, why should we then bother with visualization at all, right? Because if you think about how machine learning works, especially nowadays, as the techniques are getting more and more and more complex, and sometimes we learn how to use machine learning and we learn how to use the techniques and everything, but we don't understand exactly how it works. So it kind of feels like you have some data, then there's some machine learning magic that happens, which most people don't really care about, especially when you're talking about deep learning and things like that, when the model is so complex that you can't even understand what it's doing. But what matters is that it does something, right? You have data, you put it through this machine learning magic that comes from somewhere and we don't understand, and then poof, we have the results, and we have great things, machine learning solving everything, and make a lot of money, and companies are growing around this, and so on and so forth, right? So yeah, that's so perfect, right? Deep learning works perfectly. We build huge ensembles of classifiers, and we do all kinds of things with machine learning, and they just work and everybody's happy. Well, not really. The truth is much less interesting and much more involved than that, right? Even though maybe some people try to cover that up, but the truth is that in order to actually get to those results that look good when you see someone, making a presentation or presenting a product or something like that, the truth is that there was a huge complex process of trial and error, of trying many different new techniques, many different parameters, until you actually get to those results. Maybe not everyone actually make it to the final good results, but when you do, still there was a lot of stuff that had to happen before that. So for example, you had to prepare your data a lot, because most data come from when you actually measure it or when you actually extract it from the real world. Most data come very, very unstructured and dirty, so to speak. So you have to prepare that, and that involves a lot of iteration, of preparation. Then you have to model that. There are lots of different models available that you can try. It's not always obvious which one actually works for your data or not, or why. So sometimes you use deep learning for some things using a certain set of parameters, and sometimes you have to completely throw that away and use something else because your data has changed, and for some reason it doesn't work anymore and you don't know. But anyway, so you have to evaluate the model and then try again, then try a different one, and then maybe abandon one algorithm and try another one, and so on and so forth. And then there's also the interpretation part, right? Because even after you actually maybe get some results, then you have to actually understand what they mean and try to somehow use those results in order to get something out of that, right? And during all of this process, there are all these parameters that you have to set in all these phases. Everything here is parameterized. There are very few techniques that are not parameterized, and it's just not obvious how to change the parameters. Like, you don't know, you have a certain parameter, you don't know if it's better to, you know, lower it a little bit or put it higher a little bit. So you just have to try and try to see if something happens, and then change this thing here and there, and enable this one thing or disable that one thing, and just try it and see how it works, right? And in the end, you get all these complicated, let's say, charts and things that you, with lots of information, and it's not really that simple, right? So the point here is that machine learning is not magic. Sometimes it works very nicely, but the truth is that most of the time there is a huge human factor involved in the whole thing, right? There's a huge human participation in the whole process. Even though maybe for an expert this gets easier with time, but not everyone are experts, and not everyone become experts overnight, right? So there's a huge chunk of this thing that's actually human tasks, right? So you have, the human is somehow interacting with this process, be it through code or be it through some kind of interface, right? That is much closer to the reality. So this is just one example of what happens when you're using scikit-learn and you want to choose which model you're going to use for your data, right? So that's just like and this is a very simple, scikit-learn is a very simple framework with some basic models in it, nothing too complicated, nothing too advanced. And still, there are so many decisions that you have to make just to choose between like which kind of algorithm you want to use, and which, even in the groups of like similar algorithms, which one in there you have to choose, and so on. Even for very, very simple framework like scikit-learn, which is not so close to the state of the art anymore. So that's the point. The point is that we need visualization, okay? And visualization comes exactly at this point here. Unfortunately, my mouse is not showing. You don't see my mouse, right? So what matters is that visualization is important, because at this point here, when this person here who is completely clueless is interacting with this process, visualization can help with this, because visualization will give you an idea of the state of your system or your process or your pipeline, and will let you make better decisions as to what has to happen next. This is one, probably you will see this, or you have seen this with Andreas. So I will not be going to too much details here, because this is like a basic thing that you always see in visualization introductions. But the idea here is that from a specific perspective here, from the perspective of statistical measures such as mean, variance, and correlation, these four data sets are exactly the same. So let's say from the point of view of a computer that would use these three values in order to understand the data, they would be completely identical. But when you visualize them, they're not. So this shows how the human participation through visualization can bring many, many more insights than just by having the computer interact or the computer analyze data through some specific objective summaries or something like that. So the visualization brings much more to this process because it really taps into this more subjective, more complex power of the human being to understand things and make decisions, right? Which is still more complicated than a computer can do for now, hopefully for a little while. So then we come to, okay, so all right, maybe you understand the motivation for using visualization and instead of just machine learning, right? So you come from a background where you've probably used mostly machine learning, or you've heard mostly about machine learning, and visualization maybe just a few things here and there. You've heard about it, but maybe you didn't have so much, you know, interaction with it. But then what about visual analytics, right? Well, information visualization is this area where this huge overarching area where we study how to visualize abstract data, right? And then by abstract data, I mean data that doesn't have a very, very specific visual abstraction that comes with it, right? So, for example, when you're visualizing the human body, that's we usually don't call that information visualization, although it can also be. But let's just simplify it to say that usually we don't call that information visualization because that comes with a very specific way of seeing the human body. You know what to expect from the human body. So if you're visualizing a blood flowing, you know, a heart pumping blood through through your veins, like you know, you want to see the heart and you want to see the veins, and you know more or less how it looks. So you want to see something like that, even though it's probably not just realistically. I mean, it could have like different colors and things like that, but you're expecting to see something. You're expecting to see the heart pumping. You're expecting to see the veins and things like that. When it comes to information visualization, when you're visualizing, like, for example, stock market or something like that, then you have to, I mean, it's very abstract. So it's just information. You have to visualize it somehow that somehow makes sense. And that's what we call, in general, information visualization. Again, you're going to see this with Andreas, or you probably have already. But the truth is when you talk just about pure interactive visualization, and when the size of the data just keeps growing and growing and growing, the visualization itself by itself alone is not enough, right? Then you have to start thinking about more about this process of analyzing the data, right? So vision analytics, one way of seeing vision analytics is by thinking of it as the science of analytical reasoning facilitated by interactive visual interfaces. So we are not so much interested in the actual visual abstractions. I mean, the visual abstractions are important, but we can, in a way, more or less, consider that the fundamental problems or challenges of the actual visual representation we can assume that they are being solved elsewhere, right? They're being solved by InfoVis, by fundamental InfoVis, so to speak. And then with visual analytics, the focus is much more in how do we leverage all these things that are being researched or being created through InfoVis in order to actually support a process of analytical reasoning. So even if you use, because when it comes to information visualization, then if you look at the state of the art, for example, of information visualization research, then you're gonna see very complex, very advanced kinds of visualizations, right? For visual analytics, you don't necessarily need to use or to use such super advanced visual abstractions. You can. Nothing will stop you if it works. But the truth is that since the focus is much more in how to support an analytical reasoning, then even if you use a combination of simple visualizations that somehow interact with each other in a smart way, that is enough when it comes to visual analytics. So if the analysis process was successful, if you managed to combine these simple visualizations into an interesting process that actually brought something new, some new knowledge to the person who was interacting with this system, that is enough. All right. So again, the focus is not really on how advanced the visualization is. Of course, there are some fundamental concepts of visualization that must always be present when it comes to how you use colors, how you use shapes, and how you combine certain things. There are some fundamentals about visualization that must always be there, period. Even in the simplest of charts that you can use, even in a simple pie chart, there are some, or in a simple bar chart, there are some basic things that need to be there. So the basics of visualization will always be there. But again, you might choose some simpler visual abstraction if you think, or if you find out, if you realize that simpler visual abstraction will actually help you reach your analytical goal better than some other more complex abstraction. Okay. So yeah, the idea is that visual analytics combines the strengths of humans and computers, right? Information, scientific visualization, HCI, data mining, and so on. And this part of combining the strength of humans and computers is very, very important, especially for you in this course. Because in this course specifically, since it kind of works as a continuation of your machine learning course, we will focus very strongly on the interaction between visualization and machine learning. So you will still use machine learning in this course together with the visualization in order to build a visual analytics approach to understand better your data sets. Okay. So in general, VA is used to synthesize information. Again, I think these are based on Andreas' slides, so maybe you've already seen this before. But this is the idea of well, just in general, just detect the expected and discover the unexpected, right? So why do we have to detect the expected? Well, if you're not detecting the expected, then it kind of serves as a ground truth for you. And then if you're not detecting the expected, then maybe something is wrong with your approach, because at least the expected should be visible. And then discover the unexpected is, of course, the final goal of any kind of a data analysis techniques. You want to discover something new about your data, because that's what will give you your edge in your company or something like this. And also one part that I like here is communicate assessments effectively for action. So decision making. I think decision making is key to any kind of visual analytics approach. Not all visual analytics approaches are actually used for decision making, but it makes sense to think of it as something that will be used to support decision making. And then there's the mantra, which is analyze first, show the important zoom filter, and analyze further details on demand. This is based on the original visualization mantra. It's a little bit modified, expanded. But the idea here is to give you this insight that things have to be iterative, and it's important to first analyze or pre-process the data, let's say, somehow, then show the important parts, so you don't have to necessarily show everything at once. So you can start from an overview. Then the user can zoom in on areas where or select or filter areas that they think is more interesting. Then that like connects to a further step of analysis and details on demand. and usually you kind of do this in a back and forth way, so that the visual analysis process becomes this kind of, like, let's say, iterative process of you know, insight, deriving insights, creating hypotheses, and so on. Actually, this is illustrated here in this figure. So you start here on the left-hand side with the computer. This is what the computer is doing, as opposed to the human who is on the right-hand side. So you have data. Everything starts from the data, right? Everything comes from the data. Then it's interesting to see how the visualization and the model are not in a sequence, right? Which might be common if you think of a more like streamlined analysis process. But in this case, we consider that the visualization and the model they are more or less in parallel, because the visualization is showing the model, and through the visualization you can change the model. You can interact with the visualization, hopefully, if you have a good, interesting, advanced visual analytics system. Through the visualization, you can change the model. And the model, by changing the model, then you close the loop by updating the visualization to show the effects of that and to reflect the new state of the model, let's say. And so on and so forth. So you can see that there's this loop where you go from visualization to the model, and then the model updates the visualization. The visualization allows the user to change the model, and so on and so forth. Then you have this idea that the first thing that you do is this exploration loop. So you start by finding some things that you didn't know in a very general way. Just, okay, I didn't really notice this thing. So you find that, then you take some action, let's say, where you interact with the visualization in order to interact with that. And then the next, let's say, more higher level loop would be the verification loop, right? Because after you find something in the data, then you have an insight about that. Like, the insight actually has to be connected with something you already know about the data. Let's say you kind of have, I just got an idea from this. And that generates a hypothesis, right? So by finding this new thing, by having this new insight, you can say, oh, I wonder if this or that is true. Or I wonder if I change this parameter, or I don't know, change the data a little bit by removing this or by adding this or something like that. I wonder if this or that is going to happen. Or I wonder if I'll get better results. Or I wonder if I will be able to isolate these cases better, or something like this. So that generates a hypothesis on you by exploring this, right? And then the hypothesis leads to an action, like you go there and you do something, and the action goes back to the computer reprocesses that, updates the visualization, updates the model, and so on. And hopefully, if that goes well, you get a knowledge generation loop. So let's say you generate knowledge, like that would be ideal, right? That would be the final goal of the visual analytics approach. That would be where we would like to get to, generating new knowledge about this data set that you're exploring. Of course, this is a very abstract, very high level understanding of the whole thing, but it's intended to give you an image in your head of what it means to build a visual analytics system, an effective visual analytics system. Exactly how you get to each of these points, it's not super clear. It's not like, you know, it's not something that is written on stone that you, okay, if you do this, this, and that, you have a good visual analytics system. We're not there yet. But the most important part is that you get this idea of what it means to have a visual analytics system and how it builds up on top of just visualization, so to speak, right? Then I have this very simple small example here at the bottom, where, I mean, it could be, it's just one example. It could be like that, or it could be different, but you can see that you have this little window with 4 different types of visualization: one bar chart, a line chart, a map, and some like probably like a heat map, I guess, or something like that. And they're all showing different perspectives of the same data set. So you might interact with this in different ways in order to understand what's going on. And this is showing you different perspectives. So you're looking at the data set from different points of view and trying to integrate that somehow and understand that better. And then it goes back and forth with the actual users or decision makers that are using this to get somewhere. Right. I just wanted to make sure that this is going well. Can I go on? Do you guys have any questions? Or Kostya, can you confirm to me that you can hear me well and that everything is okay? The slides are okay and everything?
Yes, everything is working well.
Okay.
I can hear you, no problem.
Okay, good, thank you. So yeah, because sometimes I'm talking and I don't hear anything, so I don't know if I've just like disappeared. But yeah, thank you. So yeah, so I mean, ideally, this is what we would have, right? This beautiful loop of knowledge generation, this from by building up these visual analytics systems with this nice views and everything. But the reality is a bit less. Again, like in the beginning, the reality is a little bit more complex and a little bit less, let's say, perfect. The truth is that we end up generating, if we don't pay attention to what we're doing, we end up generating a lot of weird visualizations that may or may not make so much sense. Like, for example, if you have this, you know, this pie chart here where the dark blue is 93.6%, and still it's actually the pie chart shows less than half, for example, which is very weird. And you have these bar charts with lots of colors and stripes and all kinds of stuff. And at the bottom here, a bunch of points that are all overlapping. And I doubt that anyone could actually extract any insight from this. So the truth is that even though it might feel like, okay, I understand this sounds easy, sounds straightforward, it's not. And this part here specifically is about the actual basic concepts of visualization that you need to have. So just to you know, let's say reinforce that even though we're building upon visualization, so the course itself is not going to be super focused on basic concepts of visualization, even because you're having the other course for that. And the basic concepts will still be there, and the visualizations themselves will still have to make sense. Not like this. And this is also some examples of, and this is a little bit on the next level where you have the visualizations and you're kind of putting them together, and then still there are some basic concepts that we need to kind of follow in order not to just let ourselves go so much and then end up with all these crazy masses of things that are just completely overwhelming, right? That will make the user completely dizzy because nobody has any idea where to look for any information, and there's no workflow, there's no pipeline, and it becomes something completely impossible to understand and ugly, hurts our eyes, right? So there's some basic things that we need to take care. But of course, there are also good examples, right? This is for a very interesting paper called from a technique called cluster vision. It was published in 2017, so 3 years ago, not very long, but still relevant. And I like this example because when we're talking about visual analytics plus machine learning, it's actually a pretty good example, and it's available online. Later I can show you last time I checked, it was working. I'm not sure if it still is, but you can actually play with it online, and that's really interesting. So what's happening here is that this is an example of a visual analytics technique that gives you this kind of like a back end of machine learning. In this case, it's unsupervised learning, so it's clustering and dimensionality reduction. And the back end, so to speak, has these machine learning techniques that are analyzing your data and are giving you these visualizations through the front end, through the browser. And then as you play around with these visualizations, as you change parameters or as you change choices and things like that, the back end is automatically updated, and then the visualization is automatically updated, and then you get to continue through the loop. So for example, in this case, when you start from the left-hand side, the first thing that the technique will do is it will offer you many different options of possible partitions of the data set in different clusters, right? And since there are no, well, usually there is no one final perfect clustering, what the technique instead chooses to do is to say, hey, I will not tell you which clustering you should use, just like perfectly. Instead, I will give you these options, and I will give you a little bit of an insight on how good they are. And this is these little icons on the left-hand side, where you see these kind of like pentagons, distorted pentagons. This is an indication of the quality of each of these clusterings. And then the technique said, okay, I don't know which one is the best, but I'm giving you this, and you can explore and choose by yourself. And then as you choose one here, specific like clustering here, then the rest of the views would be updated to show you the data set through the perspective of these clusters. And then you can do all kinds of things. You can enable and disable some of these, the dimensions here on the bottom hand side to see in these parallel coordinates. Then you see some numbers here of, on the right hand side, some numbers of like quality, cohesion, separation, silhouette, and things like that. The distributions of the dimensions and so on and so forth. And this kind of becomes this like back and forth between choosing a certain clustering, looking at the visualizations, interacting with this, and doing that. You can also change which kind of visualization you're seeing and so on. This is a very, very, I think, like in my opinion, canonical example, so to speak, of how you interact, how you build this system that is using visualization and machine learning at the same time, and interacting, or let's say going back and forth between them, right? This is also another one. This is more like an educational thing from Google. This is the TensorFlow playground. So you can play with some deep learning networks here, and then you can, as you can see here, you can choose how many hidden layers you want to have, how many neurons in each of them, and I'll change some parameters of the deep learning, and then you see kind of like a preview of the results here on the right hand side. For example, in this case, it's these spiral data set that is supposedly hard to classify because the points are all intertwining with each other. And then you play a little bit with the parameters of the network, and then you can see, automatically you can see the preview of the results on the right hand side. So you automatically know, well, very quickly, you know if these parameters that you have set on your neural network have actually worked or not, right? Still, it's important. It's interesting to notice that, I mean, while you can definitely play with the parameters and see a preview of the results, the next step is not always, or very rarely obvious. Like, I don't know if I want to, if there's something I want to improve about this, I don't know exactly what I should do. I don't know if I should add a new hidden layer, or if I should remove some neurons from some of the hidden layers, or if I should change the connectivity patterns or something like this. I don't know, right? I don't know if I should uh, change anything about this. I don't know what's the actual impact, and that's just something very hard to actually know, because that becomes like an optimization on top of another optimization, right? And usually that's a very hard challenge, a very hard problem, setting parameters to algorithms. So in this sense, that's where the interaction between you, the user, and the system becomes important, and it becomes important to do that in a very effective and fast way, let's say, because that's where you need to somehow realize what are the actions that you need to do in order to improve it. Okay. But in this sense, it's less about exploring data and more about exploring the actual algorithm. But it's just an example. Yeah, and then what I was going to say is that we have some examples in our own research group. Like, for example, in this case, it's interactive exploration of quality and dimensionality reduction. So in this case, it's basically about exploring algorithms. But we also have other types of applications that we have done. For example, software analytics, where you use visual analytics to analyze software quality, for example. Text analytics, where we have published a couple of papers about how to use visualization to explore text documents and social media analytics, where it's also about text, but text from social media that actually comes with like some more metadata and some more information with it. Document collections for systematic reviews, for example, and so on. But the idea here is basically, it's just my conclusions, that it's actually it's what you have to keep in mind always is that you are going to work together with the computer, right? You're not going to work alone without a computer, and the computer is not going to work alone without you. So you basically have to become somehow coming to this flow of actually taking the best out of this interaction and integrating it in the best way. So if you can't beat them, join them.